So let's look at writing the formulas of ionic compounds. To write the formula of an ionic compound, you need to determine how to cancel out the charges. So you've got to figure out the smallest whole number ratio of cation charge to anion charge such that the overall charge is 0. You are not allowed to change the charge of a cation or an anion, but you can change the number of each. And the cation always comes first. All right, so let's look at some practice. Write the chemical formula of the following compounds. So, potassium iodide. All right, so to write that formula, we need to know the charges. And to find the charges, I'm going to look at the periodic table. Here's potassium in the first column, so it must have a charge of +1. And here's bromide in the column directly to the left of the noble gases, so it's going to have a charge of -1. So when I look at the charges, potassium has +1 and bromine has -1. These cancel out in a 1-to-1 ratio. So the formula is KBr. Now let's look at magnesium sulfide. And again, to find the charges, I'm going to look at the periodic table. Magnesium is in the second column, so it's always going to have a +2 charge. Sulfide is 2 columns to the left of the noble gases, so it's going to have a charge of -2. So magnesium has a charge of +2, sulfide -2. The charges cancel out in a 1-to-1 ratio. Now the charges don't always cancel out in a 1-to-1 ratio. If we look at zinc nitride, zinc always has a charge of +2, and nitride, 3 away from the noble gases, has a charge of -3. So what I look for is the least common multiple of 2 and 3, which is going to be 6. So if I can get a total charge of +6 from my zinc and -6 from my nitride, then the charges will cancel out. I can't change the charge, but I can change the number of cations I have. So 2 nitrides will give me a charge of -6, and 3 zincs will give me a charge of +6. And you may have noticed that the 3 is also the charge of the nitride and that 2 is also the charge of the zinc. That's just kind of a coincidence because when we're looking at the least common factor, that's not what we're looking at. When we look at the least common multiple of small numbers, we usually get that by multiplying numbers together. And so the least common multiple between 3 and 2 is 3 times 2, or 2 times 3. So our formula is going to be Zn3N2. So if I have 3 zincs, total charge of +6, 2 nitrides, total charge of -6, this is the formula of zinc nitride. Now let's look at copper 1 oxide. So I know what the charge of copper is. It's 1. That's what that 1 means. And if I look on the periodic table, I see that oxide is in the oxygen family, 2 away from the noble gases, so it has a charge of -2. So the charges don't cancel out in a 1-to-1 ratio, but the least common multiple between 1 and 2 is 2. So if I have 2 of my coppers, that means I'll have a total charge of +2, which will cancel out the -2 charge of the oxide. So this will be the formula of my compound, Cu2O. Copper 1 oxide, the copper has a charge of +1. Now let's look at some compounds that have polyatomic ions in them. First, lithium bicarbonate. Okay, so the first thing I'm going to do is look at my periodic table, and I find lithium. It's in the first row, so it has a positive charge. And I've memorized what the formula is for bicarbonate. Bicarbonate has a formula of HCO subscript 3 and a charge of -1. Because these charges cancel out in a ratio of 1-to-1, this is the formula for lithium bicarbonate, Li, capital H, capital C, capital O, subscript 3. All right, now let's look at calcium hypobromite. If I look at the periodic table, here is calcium right here, the second column over, so it has a charge of +2. So since calcium has a charge of +2, I need 2 of my hypobromites, which each have a charge of -1. But if I put a 2 here, if I put a 2 here, then this 2 is only referring to the oxygen and not to the bromine. And this is a totally different polyatomic ion. This is BrO2 is bromite, which is different than hypobromite. So what I have to do is I have to put my polyatomic ion in parentheses. And in any formula that I have more than one polyatomic ion, the polyatomic ion itself has to go in parentheses. So we know that the subscript here refers to the entire polyatomic ion and not just to one of the elements in the formula.